There is a series of properties that are known as being of PXML dimension type, and these tend to be coordinates or tend to be size. They always yield a numeric value, and they can be measured in a variety of different measurements. For example, you can measure them in terms of points, in terms of pica, in terms of inches, in terms of centimeters, in terms of millimeters. When you specify the unit is applied as a suffix, and the numeric is applied in the front end. So for example, 10 mm with no space between is 10 millimeters. And that's the same thing as saying 1 cm or 1 centimeter. If you say 1 in, that's an inch. That's the same as saying 6 pc or 6 pica. That's the same as saying 72 pt or 72 points. And that's the same as saying 72. Our default unit is in points. Now we said that the PXML expressions are for those properties that tend to be coordinates or tend to be sizes. And we'll have seen some of this when we think of terms of the X size or think of terms of the Y size. You should be familiar with the concept of having built-in variables min, max, and rest. Min meaning let me use the minimum extent of the current parent box. Max meaning let me use the maximum extent of the current parent box. And rest we saw takes up the remainder of the current parent box. We tended to use that when we wanted to force a page break to the next page. We saw earlier that if you want to center an object in its parent's box, you would do the max divided by 2, x equal max divided by 2, and the y equal to max divided by 2. If you wanted to position it relative to the right or to the bottom, I could do the x is equal to max minus 10 or the y is equal to max minus 20. Again, these are dealing with sizes and where they lay out on the report. To make an object take up the rest of the parent, we saw that you would just use the built-in variable of rest. For example, set the y equal to rest. PXML comes with 4 built-in functions. I can take the max of 2 expressions. I can apply the minimum of 2 expressions. I can ask for the width of a single expression, and this width is going to require to print the expression in the current font. So depending upon what the font size is, the width is going to change. Likewise, the length or height, I can pass in an expression. And again, this is the length required to print that expression in the current font. Again, if the font size changes, then I would expect the length to change. For example, to make an object wide enough to print the column header or the widest possible value from a 30-character field, I would set my X size to say it's either going to be the max of the width of the caption itself or the width of 30 M spaces. Again, the width and the length is going to return different values if the font properties are different. Now you can embed RTL in PXML if it's delimited with the curly braces. And we've seen this in a lot of the examples that we've been doing so far. So in other words, if for the PXML expression width, I need to pass in that expression. If that expression is RTL, I just need to include it inside of curly braces. So my header.field.value, an item that I'm dragging over, I assume, from my data view, that's an RTL expression. In order to use it within this PXML, I need to include it inside of these curly braces. In my second example, I want the max of, and here it's returning a number, so I don't need my quote. So I have a title width that's being brought across. I just glue that to the CM, so it's whatever number CM, or it's going to be the width of, and here I provide the string, so I use my quotes, the order line.title. So if you're embedding RTML within PXML, you just need to ensure that you include curly braces around that RTL expression. Some details about the RTL syntax. Compared to other languages, it's going to be a single line of code. So for example, field name.value.trim.length, that's a single line of code. There's no intermediate or working variables, and there are no loops.